So I'm going to do a couple more examples using the addition and subtraction formulas for sine and cosine. And one of the things that that formula can do for us is give us some new identities and new relationships between sine and cosine. So we're going to rewrite and simplify cosine of pi over 2 minus x. So I'm going to need that cosine subtraction formula. So let's remember what that is. We had cosine alpha minus beta. The cosine formulas do cosine first for both angles, cosine alpha, cosine beta. And then the cosine formulas have the opposite sign in the middle. So the subtraction formula has addition in the middle. And of course, you can have these formulas written on your cheat sheet. You absolutely don't need to memorize them. All right, so now we've got cosine pi over 2 minus x. All right, so we're going to plug in pi over 2 wherever there's an alpha and x wherever there's a beta. So I've got cosine of alpha, which is pi over 2, cosine beta, which is x, plus sine pi over 2, sine x. All right, so we can't evaluate sine x and cosine x. Those are just going to stay as they are. We don't know what x is, but we can evaluate cosine and sine of pi over 2. So cosine of pi over 2 is 0. Sine of pi over 2 up at the top of the unit circle is equal to 1. All right, so we get 0 times cosine x. That's just going to give me 0. And then 1 times sine x. So this whole thing is equal to sine x. All right, so that cosine pi over 2 minus x equals sine x. That's what we call one of our cofunction identities and gives us a relationship between sine and cosine. So our last example is to find sine of x plus y given a pile of information about x and y. I'm going to investigate that pile in just a second. The first thing I'm going to do is write down my formula for sine of alpha plus beta. So we know that sine of alpha plus beta, if we look at our cheat sheet, is sine alpha cosine beta plus cosine alpha sine beta. All right, so I need the addition formula to find sine of x plus y. So I'm just going to replace all the alphas with x's and all the betas with y's. So I'm going to do sine of x plus y is equal to sine, let's see, x is taking the place of alpha, y is taking the place of beta, an x here, and a y here. All right, so just like with the last couple of examples, we have 4 things that we need to evaluate, sine and cosine of x and y, and 2 of those things are given to us for free in the problem. So they tell me that sine x is equal to 4/5. So that means that I can replace sine x with a 4/5. They also tell me cosine of y for free. I get cosine y is -1/3. So this one is -1/3. All right, so we have 4 trig functions to evaluate, and they gave me 2 of them for free. So the majority of the work in this problem is going to come in figuring out what the values of cosine x and sine y are on the other side. Okay, so let's focus in on cosine x. Let's take some notes and write down everything that the problem tells us about x. So it tells us that sine x is equal to 4/5. And then this mysterious interval, pi over 2 less than x less than pi. All right, that interval is a very fancy way of telling you what quadrant the angle is in. Pi over 2 to pi, that's going to be quadrant 2. So we know we're in quadrant 2. All right, so when we have sine and we know what quadrant the angle is in, we learned how to use a right triangle to figure out the other trig functions. So I'm going to draw my x in quadrant 2. And then remember that we would draw a right triangle using the reference angle, so attaching to the x-axis. So I'm going to draw my reference angle, right triangle, and then we know that sine is equal to 4/5. That's opposite over hypotenuse. All right, and then we want cosine, so we need that adjacent side. So we're going to figure out that third side using the Pythagorean theorem. Right, so we have adjacent squared plus 4 squared equals 5 squared. And then that's a squared plus 16 equals 25. Subtract 16 from both sides, and I get 9. And then a is equal to plus or minus 3 when I take the square root of both sides. All right, and we kind of used a shortcut saying, all right, we're in quadrant 2, so we know that that x coordinate needs to be negative. So we're going to put a negative side on our triangle. And again, we know that we can't have a negative side length. This is just kind of a way to keep track. of whether the cosine is positive or negative. All right, so when we do adjacent over hypotenuse, we get -3/5. So that's our cosine of x, -3/5. And that makes sense that cosine would be negative in quadrant 2 if we think about our ASTC mnemonic device. All right, and then we need to do the same thing for sine y. So let's write down all of our information about y. We know that cosine y is equal to -1/3. And then they also tell us that y is between pi and 3π/2. And again, pi to 3π/2, that means I'm down in the third quadrant. All right, so I'm going to draw my y angle down in the third quadrant and then use the cosine information to get to the sine information. So here's my right triangle. Down in the third quadrant, I'm going to attach my right triangle to the x-axis, so we're making use of that reference angle. And I know that cosine is equal to adjacent over hypotenuse. So adjacent over hypotenuse. And it makes sense that that x-coordinate is negative, getting me over there into the third quadrant. So let's figure out what the opposite side is. So we have our adjacent side squared plus our opposite side squared equals 3 squared. So that gives me 1 plus b squared equals 9. B squared is equal to 8 if I subtract 1 from both sides, and then take the square root. B is equal to plus or minus square root 8. All right, so we need to choose plus or minus. We're down in the third quadrant where the y coordinate is negative, so we should also have a negative on this side, -√8. All right, and then we can figure out the sign from there. We have opposite over hypotenuse. Sine is going to be equal to -√8/3. All right, you can also rewrite that -√8 as -2√2 if you want to simplify the radical. I think we got enough going on right now, so I'm just going to leave it as the square root of 8. Let's make sure we have a plus in the middle of our formula. And let's go ahead and multiply our green and blue fractions together. So the first fraction I get, let's see, 4 times -1 gives me -4. 5 times 3 is 15. Our second two fractions, let's see, they're both negative, so it's going to turn to a positive 3√8. And then 15 on the bottom. I already have a common denominator, so we can just add. And the first one doesn't have a √8, so we're just going to write -4 plus 3√8/15. All right, so this one pulled together a lot of different information from a lot of different sections here, knowing how to use the addition formula for sine, but also thinking back to our right triangle trigonometry. So when we get together in class, we're going to move on to our double angle formulas. What happens if we have sine of 2 times alpha?